My name is Tom Brennan. This talk is Hacking by Numbers. For those that have read Twitter, it's kind of ironic. So this morning, while adding photos to OWASP Facebook profile, somebody grabbed my password on wireless, which I thought was kind of funny. So game on, good for you. And it was kind of funny to see that they posted to my Facebook wall that we should be using wireless in a closed environment like this. So it's all good stuff. So I definitely owe that gentleman a beer just for busting my chops. Also, it seems like since yesterday, there's been obviously a lot of bug conversations, and I seem to have caught a bug as well. So I apologize in advance for the weird voice and such. I'm definitely in Sweden, but really, really sick, so please bear with me. So what we're going to talk about briefly is, vulnerability issues in application security, right? So for those who have ever played the Find Waldo game, in many cases for the black box testing space, which is kind of my background, it's kind of like trying to find a needle in a haystack, right? Trying to find a potential issue within an application to be able to identify a problem and to identify where an application can potentially be compromised. So this talk is going to focus on that, but we're going to be doing it from a numbers perspective, from an inferring on a data set perspective, and I'm going to kind of cover what that means. To set a level for all, and certainly if anyone who wants these slides to do a similar talk at their own organization, our users use websites, to no surprise. Mom and dad and everyone else uses websites. But that's not really how most of us in this room see websites, right? Most of us don't really see that as a website because we're typically, if we're in attacker mode, the real question is what are several ways to attack this application? Just shout it out. There's probably multiple different ways. What's one of the things we're going to do to potentially attack this application? That we're going to look for a particular problem in the app. Anyone? Session ID. Anyone else? Again? Excellent. Those two. So we can agree that most of the time the attacker is looking at an application a little bit differently, right? So especially from a black box world of trying to understand how the app actually works to identify potentially where there's a compromise or a way to leverage the application. That's kind of the world that this talk's about. And I'm hoping at the end of the conversation we're going to be able to look at a strong situation as to a very important question. The question we're going to try to answer here is which programming languages and which industries are the most secure? Most individuals or organizations today that are security conscious, are implementing secure software development practices, and they're looking for potentially, guidance or ways to make their systems more secure. And they evaluate, a large number of technologies before they build a website. So, asking a question of, okay, well, what's potentially a development environment that is more secure than another can certainly cause a lot of debate and a lot of questions between individuals, right? So anyone want to take a stab at, potentially what environment would be the most secure to develop in today? Okay, .NET. So it must be his favorite choice. Anyone else? All right. So that's probably a good answer. So clearly with the familiarity with a specific product, and whether it's designed to be secure by default, it really comes down to a lot of different things, right? It comes down to configuration, management systems, et cetera. So what we're going to kind of do here is go through and explore that, in theory, and what is in practicality about application security. Okay, so by analyzing the assessment results of this talk, we're going to talk about what White Hat produces. Has anyone ever read a White Hat security stats report from Jeremiah Grossman? Okay, 1, 2, 3. Cool. So for many of you, this data set might be new, interesting. For others, it might be something you've already looked at. But at the end of the day, from a White Hat perspective, this data set is going to be looking at 300 customer applications ranging from everybody from eBay to PayPal to large banks and organizations that we provide services for. And we don't sell direct, by the way, so this isn't even a sales conversation. But for those that know people like Jeremiah, who was one of the actual founders of OWASP back in 2001, it's an interesting organization to work with. The data set we're going to analyze is going to be our organizations that have websites. There's going to be about 1,634 of them that are going to be in this review or in this data set. But to understand the data we're going to get into, it's important to understand that most of our customers are, they're worldwide. and you definitely use their websites probably every day. And also, the organizations that we work with or work for are typically the consulting firms around the world that use our stuff as a platform. Okay, enough said about that. So I think it's important to understand, as we get into the data set information, how we're going to classify attacks, both syntactual and what's referred to as business logic flaws. Show of hands, is anyone familiar with OWASP in the room? Web Application Security Consortium. Okay, there's a few. Certainly others that don't have their hand up. So there's another kind of a organization that's focused around web app sec space, right, as well. It's called WASP. And what we can infer based on knowledge of application security is that there's classes of problems in applications, right? There's classes. We're not looking for known problems in known systems. That would be kind of like, CVE kind of stuff, right? We're looking for a missing patch or misconfiguration or a bad version. But if you're looking for classes of problems, you can break them into a category, right? So the WASP classification of threats is broken into 24 different classes. The most current version, which came out maybe 4 weeks ago maybe, Robert Orger released it. It's now up to 27 categories. But what we're going to talk about here is the conversation that on the left, we can use technology potentially to help automate the process of finding bugs, right? So we can rest assured that we can look for things like cross-site scripting or XPath injection using tools, where that if we can configure the tool properly to accommodate the multi-step process in the application, that in fact we can potentially get a valid result back on our assessment, right? A known good. Obviously, it's human intervention for false positive reduction, but at the end of the day, a tool is really going to help us out here, and there's many of them out there, right? On the right-hand side, these are business logic flaws, right? These are things that you have to have context, you have to have state for, that a human has to be able to look at the application, right? A common way to throw this out there is that if you're looking at a banking application, and you're able to look at John's account, and John can see his, let's say, checking account, and he can see maybe a savings account. Should he be able to see another account? It's contextual. Maybe he does. Maybe the account is linked, so we can see a vacation club account or something else. So it's not as easy, you'd have to agree, to configure push button and go, because without the business logic piece, you have to understand the context of the application, right? So most people are like, yeah, that's kind of straightforward, but it's a separation of the push button, get result versus the business logic conversation. We're going to cover that as well. I'll give you another example like SQL injection. Being a syntactual type problem, we could probably agree that in most cases with verbose messaging turned on, scanners can identify this potential issue quite quickly, but so can your attacker, right? So most folks suppress verbose error messages because they don't want to give clues that they may be susceptible to this potential issue. So therefore, if you're willing to blind SQL injection, right, maybe you can test this based on a timing attack or based on some other methodology or based pure brute luck. But that, of course, will require some human intelligence as well. So some of these things are just not as black and white as some may think. From an attacker profiling perspective, I come out of DoD and did a lot of financial services work before working for my buddy Jeremiah at White Hat. But we put things into a very simplistic bucket of what we believe is truly the adversary. And I'll explain it like this. The adversary today is individuals, organizations, state-sponsored individuals that at the end of the day, they're trying to reach a common goal. Right? So bear with me. If you're looking to massively infect systems indiscriminately around the world with, let's say, an iframe injection, because your target is the end client that's using these websites, you don't really care about the particular industry that you're going after. The attack, the technology, the process to infect and cause disruption is quite sophisticated, right? It's quite sophisticated because it has to be able to leverage that particular issue. But I would call that random opportunistic, where what that means is that it's any website. If you're susceptible, you're owned, and deal with it, because now you have that problem. Well, you have a directed opportunistic, which is a little bit different. Directed opportunistic is going to be potentially an individual or team of individuals that have access to open source testing guides, like OWASP testing guide that actually can read. Maybe they have access to commercial software, maybe from their job. Maybe they have a license or two they're going to use to be malicious and don't realize that it's stamping the license into the log files. But at the end of the day, these are individuals that say, today I want to go out and hack a credit union or hack a healthcare facility or hack an organization. They're going to configure their tool, and they're going to let it run. They're probably going to find some SQL injection, cross-site scripting, because we'll validate all of this data to be quite accurate. But the directed opportunistic guy is not random at all. He's kind of targeted because he's kind of looking for a particular organization today. Fully targeted is a little bit different, right? Fully targeted is, yes, they probably have all the above skill set, right? But what they're looking at in that particular case is that it's customizing their own tools, right? So it goes back to the conversation of, are you pushing a button, right? Or are you creating the tool to be able to automate a particular task? So when you have that combination of those skill sets, it just kind of raises the game a bit, because now you don't necessarily have the same adversary, because the adversary is a little bit more complex. So if everyone's with me, I break that into 3 categories because it's the easiest way for us to determine with a threat modeling exercise, who really are you trying to protect your website against? And in our world, that customer's brand is their marketplace, right? So for most of the organizations, that's, there is no other part of their business. It is online, okay? So the websites that we're going to talk about as we dive into this talk are going to be focused on a collection, or what is a website is a collection, potentially web servers and host names, that often utilize multiple programming languages or frameworks to accomplish their goal. Okay, many applications can use this as an example, where that the host name could be eBay, which is a great example of motors.ebay.com or marketplace.ebay.com, et cetera, et cetera. There's lots of different organizations that would have multiple apps within an application. But at the end of the day, vulnerabilities in applications or a single website that may contain vulnerabilities with multiple different extensions, right? So what I'm saying here is we can drive into the conversation to look at the example, I'll use the ASP one, that in all of our client test data that we're talking about, based on extension is how I'm going to start illustrating information, and at the end of the day, you're going to be pretty much able to infer where organizations based on industry type are potentially vulnerable to problems. So stay with me. The data set overview. So this is, again, interesting for factual data because we're going to cover it in depth. 1,659 websites for customers under management. Most of these customers testing their applications at least monthly, right? That's thousands of assessments on live production code. Okay, so that's where the data set comes from. 24,286 verified vulnerabilities, right? No noise, meaning that the applications that are susceptible to problems have all been hand verified, and these issues are real and they've been reported. Secondly, if the application potentially is vulnerable to, let's say, cross-site scripting as an example, we all know there's multiple variants of cross-site scripting, right? But we're not going to report in our data set here a vulnerability that could be counted multiple times. Another example of that is this. Let's say you have SQL injection, but there's 5 different variants of the problem, right? It's only going to be reported once in my data set. Where that, just to be clear, those numbers sometimes can go crazy, right? If you can say you have vulnerable SQL injection, it's either a true or false statement in most cases. It's not going to be you're vulnerable 5 different ways, because if you're vulnerable one way, potentially you have the same issue across the board. Also, best practice findings are not included in the data set. What that means is things that are going to be less interesting. Example, if you have non-SSL components in your page on the business side, like that's, the noise report's not interesting pretty much to anybody. It's pretty much a vuln report. Like, what am I really vulnerable to, right? Okay, so we're going to highlight some of the items that we're going to go over, and then we're going to do some visuals, and you'll see kind of how this all plugs together. But the key findings of the data set report is that the languages and frameworks do not have identical security postures when deployed in the field. So what I'm saying is across the different languages that we're going to talk about, the development space for web application security, we're not seeing identical sort of results, and we're going to point out why. We have moderately different vulnerabilities across the different language bases. Perl, as an example, out of the site pieces, had the highest number of vulnerabilities.